images are analyzed on the fly. If you have high-speed recordings, you need a lot of light. Excelitas is a large company that consists of many different branches and product lines. And me, myself, I'm from Excelitas PCO. That's a German camera manufacturer since '87. And we've been acquired by Excelitas in 2001. Now we belong to a larger family, and this is something that we would like to express and show here on the Vision Show. Because, I mean, we now have access to optics. Competition, Excelitas owns QualitasTech. Many companies that deal with different aspects of light. Because we have a lot of companies that create illumination light sources.
Yeah.
We have companies that create single point detectors, avalanche photodiodes. We have companies that make optical filters.
Oh,
and companies that make lasers. And we are the only company in all of Excelitas which makes cameras. You see a combination of an industrial type of microscope that has been optimized for shortwave infrared. We have an industrial camera that covers from visible to shortwave infrared. We have an illumination LED light ring that can be made by our partners or friends from SSL, which belongs to Excelitas as well. And we have
do you need special lighting, or this is visible lighting?
No, this is different wavelengths in the near infrared and in the sphere. So we're talking about 624, 765, 940, 1200, 1300, and 1450.
Got it.
And the stand, for example, is as well from catalog. That's Linus, belongs to Excelitas as well. So
oh, wow. So you have your whole catalog on display?
More or less. And we try to show here now a potential application for a multispectral imaging. And our, let's say, flavor of multispectral is done in a way that we are recording monochrome images at the different wavelength. So we switch on one wavelength type of light, LEDs, record the image, second wavelength, third wavelength. So it's kind of a multispectral image stack that we create. And then this image stack is processed by a supervised learning network. We are using a random forest classifier for that. It's pre-trained. And for the different application, here you see, for example, the differences between the real coffee beans, a plastic coffee bean, and a chocolate coffee bean.
I see.
And you can see up there the raw images that show you as well the differences in contrast. And down there have been the confidence maps and the results. Now the whole samples move to the rice. And no, we are at walnut, sorry. Rice is next then. We are recording again. Okay. Yeah, we have different samples just to show the potential. I don't think it's very seriously that you want to, let's say, discriminate between chocolate coffee beans and real coffee beans. But it's just to show
the demo,
This is maybe much more relevant because that's the difference between walnuts and walnut shells. I mean, if you are packing walnuts, you don't want to have the shells in there.
Yeah, I see.
And you can do the same trick. You are doing a multispectral measurement, do some image processing and try to sort or differentiate between them.
Got it.
But you can do other things as well with this type of cameras.
Yeah, so now this is the processed and you could...
Exactly. This is, the red part is the walnut shell, green is walnuts, blue is background. And these are the confidence maps that have been generated by the measurement.
Got it.
Here, the separation of each of the wavelength is defined by the bandwidth of the light source. So we are simply switching the light. We don't use any filters.
Oh, I see.
We simply switch the light, which can be quite fast.
And then you process
the results.
Images.
If we want to have a smaller bandwidth, then we would need to go for laser diodes instead of LEDs. But as far as my experience is concerned, the IMAX filters are still quite expensive.
Right.
And here we have, for all of the images, the full resolution.
Yeah,
I mean, with the IMAX sub-arrays, you only have 4x4, so the net resolution is a lot smaller.
Understood.
Nevertheless, what I've seen from the advertisements on the internet, Sony is going similar pathway, so they are working on the IMX 454.
Okay.
which also has 4x4 patches of different filters. They don't tell which, but I would expect or hope that these sensors would be cheaper, because IMEC unfortunately is good but expensive. I would guess we're in the range of 40K
40K euros.
approximately.
Yeah.
Because the camera as such is in the range of, I think, 14K.
Yeah.
And you need illumination, you need the microscope, but this is totally dependent on the final application. The camera that does not run at full speed, we are just using one of the 4 channels, but nevertheless it's a couple of hundred frames per second. And this is, in contrary to the typical high-speed cameras, it doesn't have any primary image memory, but we are streaming out the data at full speed. We are using one of the, let's say, usual high-quality Jetson boards to do the image processing, so the whole data stream enters the Jetson, and then the images are analyzed on the fly. And we are looking here at flying noodles, letter noodles, and the task for the recognition is we want to identify the letters PCO, because that's the name of the company, PCO. And whenever all the 3 letters are present in an image, it's shown there and it's counted. So these are just taken as many as possible. You see what has been recognized, and whatever PCO is present in the image, it's counted. So it's just to show a powerful image processing in stream from a high-speed camera. And we are using the fine optics from Excelitas, from the different branch, from the different product line, as well as the illumination from Excelitas as well. Because if you have high-speed recordings, you need a lot of light, because high-speed means short exposure time and you need light. I don't know if you've ever been in a crash test facility. They put the car into a garage such that it keeps at this temperature, then they check everything, they switch on the light, and then it gets really warm. They optimize the settings of the lenses, and then switch off the light, and then just for the crash test is switch on again. So you need a lot of light. So that's regarding high-speed applications, and soon we are offering as well a recorder that can take full speed the data into storage. Further, if we go maybe for the next demo over there, we are trying to show multispectral imaging. It's a different task. I mean, you've heard already about multispectral imaging, so that's not really new for you. In here we have a camera that is sensitive from 400 to 1700 nanometers, so it's capable of detecting images in the near infrared as well as in the short infrared. The camera is coupled to an industrial type of microscope that has been optimized for SWIR detection, so that's for the SWIR range and the infrared. And we have different samples here belonging to the area of food. Here you see the results from the multispectral imaging, so at different wavelength images have been recorded one after the other in a serial manner. So we have a stack of images, and they are processed by a pre-trained network using a random forest classifier. Calculations are done in this computer and the results are shown. So these are the confidence map, and this is the separation between walnut shell and walnut. It's done in a Jetson board. So the Jetson controls the camera. We have very fine high resolution optics. We're using multi-color light source, but in this application we are using visible lights. You see the colors, and we just try to separate each of these different plastic samples that are in this drawer. But the whole processing is done in the Jetson, in the data stream, such that the computer is just a very cheap computer, just used as a control, and it just gets the results. So all the data are fed to the Jetson, does the processing. That's something that we would consider as a smart system. So you have a good camera and do the processing in the additional data stream and just take the results with the computer.